All right, good afternoon, everyone. So my name is Dan Taylor. I'm a program manager on the Azure Tools team at Microsoft.
My name is Nikhil Joglaker. I'm a program manager on the Visual Studio team.
And we're very, very excited to be here today to share what our teams have been working together on to really accelerate your ability to diagnose and fix issues in your production applications. Now, you may have seen the Snapshot debugger in the keynote or some of the other sessions, and we're going to be going deep into this technology during this talk, and we'll be going into profiling and other ways that you can deal with things like logs. Now, I just mentioned that we're excited. There's a lot of people here today, so I think you guys are excited too. So I want to ask you a question. Who here is excited about debugging in production? Come on! All right. Awesome. So, thank you. So our teams who have been all working really hard on this stuff will really appreciate that. Thank you so much. OK, so what is this talk all about? Right? So we talk about DevOps and the mantra of DevOps and being agile and getting your stuff to the cloud so you can get stuff to your customers faster. And so we really believe in this move fast and break things kind of idea. But that means you're doing more testing and fixing of stuff in production. And so one of the things that's kind of implied about move fast and break things is you actually need to be fixing these things faster than you're breaking them and not sort of running in circles, so to speak. So we've talked to a lot of developers and many developers like you in the audience. And what we've identified is that most of the time is spent not detecting the issue. You'll have a customer ringing on your doorstep if things are failing. But getting down to that, from that initial issue detection down to the root cause of the problem. And why is this so hard? So there's a couple of stories that we've heard, a couple of themes that we've heard. One of the reasons is just that getting access, even just getting at the logs in your server. How many people here have experienced this where you've just had to talk to an operations person just to get the logs, and you have to tell them why, right? And then you might log into the server, and you're in the wrong castle, and you have to go to a different castle. And then you get to the exception, you walk backwards up, and it's like this forensic exercise. And then the issues themselves can be caused by very nuanced things, different configuration in production, connection strings, different environments or servers that they're talking to. The actual data in production that you have is not the same as the data you have in your local or test environments, so it becomes very difficult to sort of do the forensic in what happens. And then scale, whether you're scaling from 1 developer to 100 developers or 100 users to 1 million users, scale can have all sorts of impacts on what's happening. And so you need to be able to look at the data in production to figure out what's going on. And finally, just the ability to acquire and configure the right tools so that you have the tools that you need when the issue happens. We find that a lot of people don't invest up front in acquiring the tools until they get into that red field sort of everything's on fire situation. And so we're going to be telling you a few stories today. First, about how you can quickly identify issues in production with built-in tools, with our application map, our correlation of logs, and all these great things. And then once you've identified that issue in production, how you get the data that you need to actually get to that root cause quickly, and we'll be using the Snapshot debugger to show you how you get that. And then finally, we'll dig into the profiler so you can see what your code is doing over time in your scaled production service. And we're going to be covering a couple of products today. We're going to be showing application insights. Why application insights? Because it's the built-in APM monitoring and diagnostics solution that comes with Azure for application developers. We'll be going through application map, correlation, and analytics in the first part, and then we'll spend some time on profiler later. And then there's the Snapshot debugger. So why do we say the Snapshot debugger? Well, it's this thing that kind of transcends products and teams. Nikhil and I are here from 2 different teams working together, and it's really this concept where we have an experience in the Application Insights portal for debugging snapshots, and we have an experience in Visual Studio Enterprise for that as well. And we'll be focusing on Azure App Service with .NET for this initial release. OK, with that, we're going to go into the first section about finding issues in production. And I like to go right into the demo of our app. So before I dive in, one thing I want to show is I've got this simple ASP.NET application that I've published to Azure websites, very simple application. I just want to show you how easy it is to turn on application insights to get the built-in monitoring. So this is an application running in Azure App Service. If I go to this Azure App Service in Azure, simply if I go to the Application Insights tab, and I click Create New Resource, and I simply click OK, that's just going to go and turn on Application Insights. And this is free, by the way. This is included. It's got a free tier. So as a developer, you can just go use this. You don't need to ask anyone for permission or ask your IT organization for a credit card. And after that turns on, then it asks you to instrument your app. And one click, and then you've got your application instrumented, and you'll be able to have your logs and traces and your requests all being sent to Application Insights in the cloud. OK, so once I have this, I can pin that information to my dashboards, and I can explore all of those different things. So next, I'm going to flip over to an application with a problem. Here I am in my Visitors app. And when I click on this button here to view this tile, it takes a really long time to load. And eventually, it returns, and this CRM data never appears. So we're going to go ahead and diagnose this problem really quickly using the latest state-of-the-art tools. And so I've printed off all of the logs from my server over the past day. And I'm going to ask Nikhil to go ahead and look at the logs and tell me what's going on.
You're not serious, are you?
Please look through the logs. But Nikhil, those were just the logs from the front end. I still have the logs from the back end. I think he's trying to tell me there must be a better way. So I've got my dashboard here for the Visitors application, and I've pinned various pieces of Application Insights here. And I can immediately see my application's got a front end and back end component, and that there's some failures happening, really all up at a glance. So I can click into here to go into the application map, and it shows me more details. And I can see the front end is calling the back end here, and that the back end's failing. And the front end also makes some HTTP calls and makes some SQL calls. So I can immediately, as a developer, reason about this application.
Wait, Dan, so this map is automatically made for you just because you got Application Insights?
That's correct. With the latest Application Insights SDK, we automatically add correlation between all of the calls between the servers so that you can see this map and all the arrows drawn between them. Now, that applies when you're using HTTP to talk to different servers. So when I click on one of these nodes, it shows me more information about the errors that are happening on that node. And it also shows me here that almost 100% of my calls from my front end to my back end are failing. So I can go ahead and I can click on that back end, and it will list for me the exceptions all bucketized and counted. So remember that stack of papers? Think about when you're looking through your logs and you're sort of walking backwards and you're just seeing exceptions flying by. We've gone ahead and counted all of the different failures and grouped them by the HTTP operation in which they occur. And I can click on this exception here, and it's going to tell me right away that an error occurred accessing the database, and that I might have a bad connection string. So this is a very simple error that is very obvious for me. But before I go in and check the connection string, I'm going to show you a few different tools that I have available to me to sort of try and triage and root cause this. So down here, it says this little button that says Show Telemetry for this operation. If I click that, it's actually going to bring up a correlated list of all the logs from my front end to the back end for this individual operation in my application. So I can see the request coming into the front end, a request, a dependency call, HTTP call out to the back end, the incoming call into the back end, and then a trace in the back end that says, I'm in the back end. So I'm correlating this information from the back end, from front end to the back end, and I can see sort of one thread of activity through it. And eventually, it shows me the exception that occurred. All right? So that's very useful as I'm going through the forensics. And again, we've automatically added headers to all the HTTP calls so we can piece this story together for you. But that's not all. So Application Insights is built upon this application analytics backend, which is a very highly scalable solution. It's a very highly scalable, rich document querying database. And it's got all sorts of different powerful ways that if you want to dig deeper and ask more questions about what's going on, I can quickly come in here and open a new tab. So I'm not going to get too much into the query language today, but if I just type exceptions here and hit Shift-Enter, it's going to list out all of the exceptions that have occurred in my application. And this is kind of what you might see in that log file that you have. But rather than looking at these exceptions one at a time, I can ask further questions. Like I can say, how many exceptions are firing over time? And I can say, summarize count. And I'm going to group this by 5-minute increments. And I'm going to say by bin timestamp. So I'm going to bin the timestamp into 5-minute intervals, 5M. So just pull that query up there. And so when I run this, it gives me the table, but then I can just say render time chart. So that's going to turn that into a time chart. And what's really cool about this is I can see there's pretty consistently about 5 exceptions being thrown in every 5-minute increment. But Application Insights has also showed me these spikes on the graph where there was different features or nuances, anomalies that were detected. And I can just click on that, and it's going to automatically detect what the patterns are, what was different at this spike, and it's going to group this into with pattern and without pattern. So it actually comes in here and it says, hey, there was just there was 8 exceptions that were thrown at this time that had a pattern. And if I click Show All here, it will tell me that this pattern was all to this API visitors 3 API call. So it's automatically done a lot of that sort of forensics that I would have to do as a developer and just surfaces the patterns that are interesting to me. And these things can often help you get to the root cause very quickly. So other things I can do in here, I can just type something like exceptions, and then I can use a tool called AutoCluster, which allows me to automatically bucket my query into different buckets. So if I say evaluate AutoCluster, that's going to go ahead and figure out what all the unique and interesting events are here. And it's going to say that 98% of my exceptions are this system component model.win32 exception. And if I zoom out here, anywhere, all these fields here are the common properties across all of the exceptions that are being thrown. So sometimes you have an issue that only occurs in a specific region or a specific data center or a specific customer. This will automatically pull that pattern out for you so that you can see where those failures are coming from. And you can type in any query here. So for example, I can say requests where success equals false. So this is all the failed requests. And by the way, this piping syntax here, each line inherits from the previous line, so it kind of acts like a filter. So each line filters the previous line. So I can kind of group and shape all this information. So I can say, I can do AutoCluster on all my failed requests. And again, it's going to give me the common properties of those failed requests. So it says that 58% of my failed requests are to this CRM data API call, which is what I saw in the application map. And then it allows me to then again see all of the common properties. It's all to the API with the URL 1. That's where all my availability tests are currently hitting right now.
So Dan, you showed that there's requests, exceptions. All these things exist in analytics, and I can query them out?
That's correct.
How much data can I put in there?
How much data can you put in here? Well, actually, we have clusters of these set up at Microsoft with hundreds and hundreds of terabytes of data, and the performance is amazing. So this is a great, highly scalable solution that you can use. You can start free, and it grows with your data volume. You don't have to worry about standing up all these additional servers to make it scale and manage them. All right, so that was a quick tour of how you can use a lot of the features built into Azure for quickly triaging, pinpointing, and finding those issues. So we showed the application map, how it shows you the health of your layers, your front end, your back end, so you can see where the problems are. And it groups all of the failures into buckets on the right-hand side so you can see what the common patterns are or what the most significant ones are. And then you can click into that, and you get information about those exceptions. And I also showed how the correlated tracing across all the servers lets you trace one thread of execution from your front end to back end. And you don't have to go in and add all these correlation IDs to your code everywhere to make it work. And then I showed how you can use the analytics engine built into Application Insights to dig deeper into your application in production and use cool things like AutoCluster, which intelligently can find the patterns for you so that you can identify the root cause.
Thank you, Dan. So Dan just gave us a great overview of how application insights can help you isolate out what could be the cause of an error that happens in your production environment. I'm going to go to the next step in that when you have a problem that you can look through your application map and other tools to try and narrow down why it's happening, it's another problem entirely to get to the root cause of this is the actual issue that propagated up and created these exceptions and created this issue in my application. So we've heard all kinds of stories of people dealing with their production environment and dealing with errors that happen in production. We've heard people redeploying their applications after inserting more logs just to get additional data that they can try to debug and try to root cause an issue. How many people here have actually had to redeploy with more logs and had to almost everyone's hands
Wow, that's
up?
everybody.
We've heard people have to try and impersonate a customer. Of course, when you write your own code, you deploy it up, and a customer does something that's completely weird, and what were you even doing? And you might have to call up a customer and ask them to give you a full workthrough of what they were doing with your application that caused it to break unexpectedly. Finally, we hear stories about people replicating production databases into a staging or local environment just to get closer to a production debugging experience. And in the worst case scenario, people actually attach a debugger to production. This is all kinds of scary. So
Doesn't that take down the server?
yeah, you hit a breakpoint, it's done. We actually took a video of an actual Microsoft engineer trying to debug a production environment, and it looked something like this. And the train just keeps coming.
Is that an HTML5 train?
Well, we kept thinking there has to be a better way. So we built, don't give me those. We built the Snapshot debugger for Azure. And some of you might have seen the Snapshot debugger earlier today. In a nutshell, it's a debugger that we've designed from the ground up to be used in a production environment, to be safe to use against production and production data. When we designed the Snapshot debugger, we had 3 key principles in mind. The first principle was that the Snapshot debugger should have a minimal impact to production. This means that you should be able to use it in your production environment as it is, without any kind of redeployment, and without slowing down or affecting production much at all. Second, we wanted to support highly distributed applications. So no matter if you were running at app services or hundreds of VMs or in Service Fabric, we would like to support your application. And finally, we want the Snapshot debugger to be secure. So for the rest of my demo, you can assume that I have access to the Snapshot debugger because I've worked with my organization to access role-based access to this debugger and to this data. So I'm going to jump into the demo of the Snapshot debugger. Can you switch? And I am going to start right where Dan left off on the application map. So Dan pointed out an issue where about 100% of the requests that were going out into the CRM backend were failing. Now this is bad, and Dan, of course, found the issue that was causing that. I'm more concerned about these 8.6% of failures that are happening in my front end. As application developers, I want 0 errors, and this does not stand well. So I'm going to click into it and try to figure out what's going on.
Are you sure you don't want a little bit of errors?
I'm pretty sure about that.
Okay.
So I click into my front end here, and I see that there's these index out of bounds exceptions that are occurring in my application. This is something that's weird, and maybe I can drill into a little bit to figure out what was going wrong. So I can click this index out of range exception, and I get a few details about this exception, what was its message, and a few things there. If you notice up here, I actually have an open debug snapshot button that will give you a much more granular information as to what happened here. So I'm going to click that.
How did that snapshot get collected?
So I'll tell you what happened. So we have a snapshot here of actual debug information that was analyzed by Visual Studio and put up in the cloud. When there are exceptions happening in your application, we intelligently look through the exceptions, and we take a snapshot of, hey, this is maybe something bad that's happening in your app that you can take a deeper look at. We collect this snapshot that contains your call stack, your variables, and other information, and automatically provide it to you through the application map and through application insights. So I have all this great debugging data at my fingertips that's automatically collected for me by App Insights. Now, this is a great overview of exactly the point of time of that failure that I can get some level of details into. But I can actually just download this snapshot and open it up in Visual Studio to get a much more granular debugging experience. So I'm going to download this snapshot, but I actually have one already downloaded, which I'm going to open up. And when I open this snapshot, it'll take a couple of seconds to actually get up and going. I can start debugging in that actual point in code when that failure had happened. So this looks a lot like the debugger. I have the exception message that was thrown, and I have the line of code and my source code as to why this error, or where this error had happened.
You know, Nikhil, I really like what I'm seeing here, but you know, when I'm using Visual Studio, I like to type in expressions and ask questions about the dump file. Can I do that here?
Yeah, absolutely. So if I'm curious about a specific thing here, suppose I was curious about this visitors object, I could go into my watch window and I can add in a visitor. I get a nice IntelliSense experience that highlights up for me. And I can hit enter there, and it will actually evaluate what that variable is and let me dig through that object. Now, going back to this actual error, it seems that there was an index out of range exception that was thrown because of the security code that was passed into my application. If I hover over the security code, it looks like I'm getting an empty security code, which is really, really strange to me who developed this application.
I don't remember seeing that in the UI.
No. If you, in the actual application itself, there's actually no way to set a security code. I have no idea why a security code was set at all and how it was set to this value, because I specifically did not do this in the application. So to try and analyze this further, I'm going to pull up Visual Studio and use another feature of the snapshot debugger that lets me interactively set snap points wherever I want to try and get more details as to why, as to something that's going wrong in my application. So to do this, I have Visual Studio open, and I'm going to put it in a snapshot debugging mode. In this mode, you can see that Visual Studio is connected out into Azure, and it is debugging my service as it is running in production safely. This looks similar to a debugging mode, but I can come to a particular line of code and add a snap point. I'm going to do that right here in this update controller, because I have a hypothesis that someone is trying to force in a security code that will be used by my system. So I'm going to come here, and when I click on the gutter here, a snap point gets added to my application at this line. When I turn this snap point on, it tells my production server when this code path gets hit to take a snapshot and bring those details back into Visual Studio for me. Now, this website is actually live and it's running. There's actually a couple people in this room here hitting it today. And I can see that after a few seconds, that, oh wait, I got a snapshot in Visual Studio. That means someone who's hitting this site has actually run that code path And Visual Studio has captured a snapshot for me to come and analyze as to what had happened exactly when that code had run. So I can double click into this snapshot and attach to it to start analyzing what was going on at that particular point in time.
Is your website still running?
The website is still up and fine. Anyone who's accessing this website, they're perfectly fine. They actually have no idea I'm debugging this right now. When I'm at this snapshot, I can view locals. I can add things to my watch window and see things in my watch window. And I have my call stack and all kinds of other great debugging information. So I'm going to hover over this and see if this visitor actually has the security code associated with it. And I can see, no, it doesn't. There is no security code here. And the reason there is no security code here is because this is probably one of those 90 to 95% of requests that come into my server that are perfectly fine. There's no problem here. And that doesn't really help me because I really need to focus down into a request coming into my server that is setting a security code, that is bad, that is something I can do something about. So what I can do here is I can come into this snap point and say, hey, I want to set a condition. I only want to take a snapshot when this bad thing happens. I can say I want a condition to only take a snapshot when the visitor's security code was not null. I can turn that condition on and turn that snapshot back on in production.
So you just clicked update collection. Can you tell me what that does?
Yeah, so when we have a snap point placed in your code, we will take just one snapshot of that particular code path being run. When you hit update collection, we can turn that snap point back on for any other settings or details that you might have put into that snap point. So I've done this, and after a few seconds, oh, wait, here's another snapshot. If I double click into this snapshot would have only been taken when the security code was set that identifies that there could have been an error in the application. And once I'm on this snapshot, I can view the visitor and see, there was a security code that was set to HoloLens, and who was, wait, this is Dan. This is Dan Taylor who set the security code. What are you doing?
I got my botnet running backstage. I really want to get into the HoloLens building, so I'm trying to.
So it appears that Dan is manually putting in requests to my website, trying to force in a security code by passing in that security code, and it's actually being accepted in my application to go then and do bad things on the other side.
So that value there, that went into the database.
Yeah, this went into my database. It's propagated through the rest of my app, and you actually got access by setting that security code manually.
So that's why my GET request started failing.
Yep, exactly.
Makes sense.
So let's pause for a second. There was quite a bit of magic that happened in the background that pieces up a snap point with a snapshot to be taken. And where's the slides? I will give a quick explanation of what we're doing in the background. So when you're debugging locally, it's a relatively easy problem. There's one client, there's one server, you control them both, and it's easy to piece together something to try and get to the root cause of an issue. Production is scary. Lots of servers, lots of clients. You could be one of the clients hitting in to the backend server. And there's a lot going on all at once. So with the snapshot debugger, we try to really narrow down to the actual request that is a problem for you and give you details and data just for that request. So when you add a snap point to your application, we actually turn that snap point on every single server that is running your application. Now, that's great. And whenever the first server hits that particular snap point under the conditions you specify, we will focus only on that server for the rest of the snap points that come in and hit your code. Now, that solves some of the problem because the rest of the servers and any clients that are not hitting that particular target server go away. And it's a little simpler debugging problem. However, that one server can also have multiple clients that are sending in requests, and multiple clients could also be hitting snap points at the same time. So we did the same thing for a client. When you have multiple snap points in your application, we can ensure that only one particular client that hits the correct conditions will capture snapshots for you on the other end. Now, we can narrow down that based on your conditions to one server and one client. And because of that, it's a lot happier problem and a lot simpler than dealing with a large production environment with a ton of things going on at once. Now, that manifests itself in Visual Studio. Do you want to switch back? If I set multiple snap points throughout my application, I'll just set a couple here, and turn them all on at once. When a request comes into the server that agrees with that particular condition I've set, it'll go through and capture all of the snap points that I've turned on for that one request. Now, that means I can click through any of these snapshots that were taken and be guaranteed that the data is all correct for that one request that was bad that came into my application. Now, this is great. It really lets me narrow down into my production issues and to have a fully fledged debugging experience into figuring out what was going wrong. Now, as a next step, this is great that I figured out that there is a security code getting pushed into my application that might be something that I can go fix on my backend later. But for right now, I want to do something different. I want to just get every single user who's coming into my application and setting this, trying to force in a security code, and get a log message that says, hey, Dan Taylor has broken my system, or something like that. If I want to add this kind of logging to my application today, I would have to go through, edit my code, redeploy my application, go through any CI/CD process I have, and it's a pain to get any additional logging back into production. With a snapshot debugger, it's a lot easier in that at this snapshot, instead of taking a snapshot, I can just take a log message that, sorry. I can just create a log message that should be taken at that particular line of code when the specific conditions are met. So I want to take a new log message here. I want to say, hey, there's a security breach, and whoever was the visitor that came into the system and tried to put in a bad security code, I want to grab their name and say, so-and-so passed in a bad security code. So I've created this log message, and I've told the snapshot debugger to take the action to use this log message and inject that into my application on my production servers. So I'm going to turn this log point on, and whenever that particular code path gets run, I get additional, whoa, there's a lot going on here.
That's that botnet again.
There's Dan Taylor, I get more log messages whenever that particular code path gets run, and these additional logs just start showing up inside Visual Studio. I have additional details right on the spot when I need them. So these log messages are great. They show up right in Visual Studio where you want them. The other cool thing about them is for the .NET framework, we are actually using the system.diagnostics.tracing to create these log messages. So if you are using any kind of other, if you're using any kind of logging frameworks or aggregators that can pick up diagnostics tracing, these will automatically flow into the rest of your logs. I personally am using App Insights to manage all my logs, not these printed out stacks of crap. But If I come into my application insights analytics portal and look through all of my traces that are going through my application, any additional log that I've added also shows up here.
So you're saying that if I already have all these systems set up for logging, these log points will just augment that with more information that helps me root cause the issue.
Exactly. Click a button, you can add logs wherever you need them, when you need them. Can you switch on? So, as a recap, we've gone over a lot of great ways to debug your application as it's in production. We went over the application insights automatic collection of snapshots, in which we can go to errors that are regularly happening on your system and take a snapshot exactly where these errors are happening and give you that point in time and give you that this error had happened and let you debug into your application right then and there. This feature is actually in public preview. We shipped it today, so we're quite excited about that. To start using it, there's a couple things you have to do. You have to add the snapshot collector NuGet package into your application right now. And you have to actually view these snapshots into Visual Studio, you have to install a v6 that allows you to do so. There's some details at the end of the presentation on getting onboarded into that kind of experience. We also saw the ability to take snap points and log points in Visual Studio when and where you need them. This functionality is right now all in private preview. It will be more generally available later this summer. And we have a sign-up link at the end of our talk to get access to these early bits and to try out that kind of thing. So debugging Azure has never been easier. I'm going to pass it back to Dan to, once you've gone through and fixed any kinds of issues that might be happening in your production environment, maybe you want to take a closer look at the performance and scale of your application to see if there's things you can do there.
Great, thanks, Nikhil. That was pretty cool. So I'm going to talk about how, once you've got your site functioning, as Nikhil says, how you make sure that it's delivering a great experience to your users and you can actually afford to run it in the cloud. So I'm going to be talking about optimizing performance. So why do you want to optimize performance? Like I said, you want to deliver that great user experience. And just a rule of thumb that I like to use is that you want your pages to load in less than 500 milliseconds. Less than 100 milliseconds, even better. But there's been numerous studies published that the faster your websites load, the better your user retention, user engagement, and revenue is for your company. Also, because you want to minimize the cost of using resources in the cloud. And the way I like to think about it is that what you want to do is you want to minimize overall what your code is doing over time. Because when your code is running, it's either delivering a bad experience for users if it's taking a long time, or the longer your code is running, the more resources in the cloud it can use. So thinking about the anatomy of a typical request, there's some network traffic that comes in when a request comes in from an external website or user. Then you run some code that processes the inputs, decides what to do, and then it makes a database or HTTP call. And then it gets the results from those HTTP calls back, it processes them, and then it does more network traffic to return the results back to the user. Now, this is somewhat of a simple model, but it's really effective. And I like to say that, or the way I like to think about it, is that my code is either spending time waiting or it's spending time executing on the CPU. So this is one request. So what happens when another request comes in just after that first one into the same system? So in this case, let's think about it in the case where I've got a single CPU VM running in the cloud. That second request is going to come in. It's going to send some network traffic. And then it's going to wait a little bit for the first request to be done using the CPU before it processes its inputs. And then it makes the same database call. But because of this resource contention, it's going to take a little bit longer for that request to execute.
Wait. So what you're saying is the second request, because it's still dealing with the same resources the first request is dealing with, it will take longer, and any more requests will just slow down the system even more.
That's exactly right. So your code is either waiting, executing on the CPU, or it's blocked on resource contention. So using these simple models in mind, that's why I like to say, if you just minimize what your code is doing over time, you can deliver a great user experience and minimize the cost of those cloud resources. So what are some different performance issues that you can have in a production environment? There's a class of issues that affect every single request that every single user sees in your system. So think about your home page, right? Every user that sees the home page sees that same set of activities involved in processing the request. And so things like using entity framework in certain ways, or just rendering CSHTML, or making calls out to blob storage, HTTP calls. These are things that you have to do in order to serve up the majority of your traffic. So if you can reduce the typical amount of time you spend on a request, you can really deliver a great user experience to a majority of your users. And then there's performance issues that happen either at scale or somewhat infrequently. These are hard to reproduce. And so things like resources being overutilized, maybe got way too many requests that are trying to use the same CPU or memory. For a long tail issue, something like garbage collection can kick in at the last minute and take seconds for some users. And then there's situations where I've got lock or resource contention on my server where multiple requests are just stuck blocked on a particular resource. And this is something that can happen more at scale as the load on your servers kind of increase. So to solve these problems, we've introduced the Application Insights Profiler. So the Application Insights Profiler helps you see what your code is doing over time. So it helps you get that insight into how to deliver that great experience and properly utilize the resources that you have in the cloud. And it does this by capturing data from production. So it runs for 2 minutes out of every hour on your production service. So you get a sampling of requests automatically without having to do anything into sample traces that happen for various sample requests. So during that 2 minutes, it captures all of the requests that happen during that time. Some other products, when they run their profiler, they might give you only the slowest request that happens during a certain minute interval. If you have 1,000 requests that happen in this 2-minute period of time, we'll show you 1,000 samples that you can then go look at so you can see your typical performance as well as your slow long-tail performance. And this data is stored for 5 days, and this is actually included with Application Insights at no additional charge. So you can start using it, again, without having to worry about it. There's nothing stopping you from doing this. And it takes this information and it segments it into the typical performance and the long-tail performance. And so we think about this as percentiles. The median being your 50th percentile represents what 50% of your users see, and that's the typical performance. And then we look at the 95th percentile usually to represent the long-tail performance, because at the 95th percentile of your request, 5% of your users are experiencing that performance or slower. So I'm going to dive right in and show you what this looks like. So I've got a website here, and I'm going to ask you how many people here have seen this website. Has anyone seen this website before, this Fabricam sample? OK, a few people. So I've been at Microsoft for about 6 years, and this application was around when I started at Microsoft, and it's been used for a while. So I looked at it and said, I wonder what kind of performance issues are sort of stuck in this old, crufty application. It's just a simple application that lets you look at support tickets for installing fiber optic network connections and things like that. So we got the home page here that everyone looks at, and then we've got our service tickets page. It loads kind of OK, half a second to a second. And we've got our customer page and various things like that. You click the details and it loads up. That details was really fast. So that's what I see when I'm using the application, but I want to use the profiler to figure out what does the full picture look like? What are all the different users of my application seeing? So I'm going to come into Application Insights where I've got this overview timeline. It shows me my server response time over time. And I can just click on this, and it opens the performance view of my application. And when I open this, I see various charts that show me my server response time over time. I can see that overall I'm hovering around 250 to 500 milliseconds. I can also see times here when the load increased on my server. So I actually ran some load tests on this application throughout the day. It's serving up about 88,000 requests during this time. So down in the table below, I see all of the operations in my application. I can see the name of each operation. So I've got my home index, that service tickets, and the customer details, as well as an API call for the customer details. And it lists for me the median, the 95th percentile, and the count. So using this information, I can sort of prioritize which area of my website I want to spend time optimizing performance. So things that get hit a lot, I might want to spend some time on. In this case, I'm going to start with my home page here, which has a median response time of 570 milliseconds. And so I'd like to make that faster. So the profiler, what it has done, it has gone in and collected these examples here. Now let me just take a quick detour here to show you how to actually turn on the profiler. So I'm in this performance tab, and I just want to click this configure button. And this will allow me to configure the application insights profiler. It'll show me all of the applications that are associated with this, and I can just click start profiling here. And that's all I have to do. So when it's running, it collects those 2-minute windows of time, and it populates this examples column. So if I click on this examples column here, that button there, it's going to provide me all of the various requests that were captured, and it breaks them down into those percentile buckets. So you can look at your slowest request by default, which is my 99th percentile, and I can see that even though the median was about 500 milliseconds, I've got requests here that are taking 3, 4, 5, 6 seconds worth of time. And on the right-hand side, it shows me that view of what code was running over time. And so this is a call tree here. And on the left-hand side is the method name or the event of what's happening. And it shows me about, for example, when processing this request overall, it took 10 seconds. And then my home index page took 7 seconds worth of time. And then I get various information about where I was.
Wait. At the bottom there, it says block time. What is block time?
So block time is when my application is sitting there waiting either on resources to become available or waiting for information to be returned back from an external server. And actually, if you click into this, very often you'll find, and I'm not going to show this here because it's a really big stack, but if you click Show Framework Dependencies, this will go all the way down to the kernel of the operating system in terms of what code was running. And you'll actually see places where you're spending time waiting on context switches, on being swapped in or swapped out for other threads. All that information is available in these call stacks, so you get very rich analysis into what code was doing over time. So in this case, I'm going to flip over to a more typical request. I'm going to focus in on the 600 millisecond request here. And it's going to show me, in this case, for the typical user, I'm just going to collapse some of these here. I spend a bunch of time. I spend about 240 milliseconds talking to Azure Queues. I spend 225 milliseconds talking to Azure Blobs.
So scroll over to the right there. Those blue lines on that right side, what does that mean?
That's a great question. So this is actually showing me that timeline of execution of all of these pieces of code. So it's showing me that at the beginning of my request, I was actually making an HTTP call here, I believe. Oh, that was actually rendering CSHTML at the very beginning of my request. And then it made a call out to Azure Blob Store, and then it made a call out to Azure Queue. Now, let's take a look further down. It shows me that I made a call to SQL database, and it only took 1 millisecond, and it was at the very end of my request here, just this little blip of time.
So the database wasn't actually the problem.
No, in this case, the database wasn't the issue. The database is not always the problem. So if I take a look at my code, Here, not only does it tell me that I was making these HTTP calls out, but if I expand the individual lines, it actually tells me which functions in code we're executing. So in this case, it tells me that this call was made from my home index, this get blob storage data function. So if I go into my Fabricam application, here it says I can see the calls to get blob data and get storage queue data. And notice these are happening one after the other. Just like we saw in that timeline, there was one happening after the other. And so one thing we could do here is we could have these pieces of code execute in parallel rather than one after the other, because there's no dependencies on them. And so that would probably speed up my application by 100 milliseconds or maybe 200 milliseconds for every single user that hits my home page. Now let's take a look at a different request. This time I'm going to take a look at that service tickets index page. This one, about 340 milliseconds is the median performance. I'm going to click on examples again, and I'm going to look again at the typical case. So this one here took 366 milliseconds. So again, I'm looking at individual requests. And this time, I'm expanding my code here, and I see that I've got some CPU time spent in this handle entity append only, and that's taking about 170 milliseconds of time total. But if I look at the CPU time, that's 100 milliseconds of CPU time spent in this particular method here. Now, think about that. If I've got one CPU on my server, and this one request takes 100 milliseconds of time in this handle entity append only, that means I can only handle 10 requests per second maximum just for this one piece of code. Right? So this is something that's actually limiting my ability to scale my service. So what do I do next? Well, what I usually do is I take that, it says handle entity append only. I'm going to plop that into search. I'm going to put the word slow on the end. And you'll find that, oh, I didn't type it right, but the search engine figured it out. You'll find that often with these pieces of code, you can find other people online who've hit very slow performance patterns and who've got various advice. So in this case, I've kind of come across this blog post here, and it's got, and it talks to me about all the data tracking that happens with Entity Framework. So it says that as various pieces of information come back, often you have to, there's all this change tracking that has to happen with Entity Framework. Sorry, I'm stuck on Zoom here as I'm trying to slow down. So I read through this blog post, and at the very end, it tells me that when I'm running a query, if I just add .asNoTracking, if it's a read-only query, Entity Framework doesn't have to keep track of all my objects in order to, if I make a future update, because it keeps track of this stuff in case I need to write back to the database. So if I go into this application here, if I go to my service tickets controller, where that index comes in, I see I have this function called to this all-including method. I'm actually going to right-click and say go to implementation, which in this case skips through the interface and goes right to the implementing method. And here, this is where I'm making that this.context.service-tickets call. So I can just come in here, and sure enough, if I just type asNoTracking, then that should fix the performance issue. That should give me 100 milliseconds of CPU back. And if I look back at that performance trace, I also notice there's a bunch of time spent in this action link thing. And that's 90 milliseconds of CPU time. So again, I'm going to come in here and type action link slow. This is literally what I did to try and figure out the performance issues. And I find here this Stack Overflow article where someone has said, hey, I'm using action links in a tight loop, and I find that if I create an action link ahead of time and then just use string substitution to modify the variables, that it's a lot faster. So now I'm going to go look through my CS/HTML to see if there's a place where I'm doing an action link in a tight loop. So I'm going to go to my service tickets homepage here. And if I scroll down, sure enough, there's a for each loop with this HTML action link here. So I can hoist this action link creation out of the loop and then I can do some sort of string substitution, or maybe I can avoid using action links at all, and that would save me about 90 milliseconds of CPU on every single request and allow me to scale a lot more on the server. So now we're having fun here. So as I'm going into, let's just look at one more, that customer details page. So I click on that Get Customer Details, and I'm actually going to look at the backend API, because in this case, it tells me that most API calls are fast, 16 milliseconds. You know, in 16 milliseconds, you can't do a whole lot, you can't use a lot of resources. But the 95th percentile here is 224 milliseconds. So I'm wondering what's going on at the 95th percentile. Why are some of these requests taking a long time? So I'm going to click into those examples. And in this case, I'm going to pick, oh, it selected the slowest one automatically. And then in this case, the profiler said that 99% of this request was spent in lock contention. So I've got a bunch of requests who are all waiting on a single lock. And the profiler tree view here shows me that where that lock contention occurred, this is the CLR function for lock contention, and it happened inside of that customer repository.find method, and the when chart shows me that it took up the majority of the duration of the request. So all I need to do is go into that customer repository find method, which is inside of here. Open my customer repository. And sure enough, somebody has put a lock around the call to the database. So only one person, only one request at a time can come in here and make a call to the database. And so normally, the requests only take 16 milliseconds. But when I ran my load tests, and if I go back and look at my load tests, it was during these times here where those requests started to spike up. And I can actually click and drag here on this graph to filter this table to those specific ranges of time. And I can see those, the values in the table and look at examples during the time when those load tests actually occurred to drill into that. OK. So we just saw how you could use the profiler to see what code was running over time and give a better experience to your users and help you reduce your cloud computing costs. So you can enable the profiler from the performance blade of Application Insights. And this works for .NET Framework and .NET Core. And we're announcing that this is GA'd for Azure App Service. And again, it's included at no additional charge with Application Insights. It does require that you are on one of the paid tiers of App Service because we need enough capacity to run the profiler. And we're also announcing a preview available that you can try out for VMs, Service Fabric, and Cloud Services. So again, this profiler allows you to prioritize which operations to look at by looking at the count and the percentiles to help you differentiate between the typical user's performance and your long-tail performance at the 95th percentile. And then you can drill into example requests to see what code was running over time for specific examples in your application. OK, so we just covered a lot of really exciting stuff that we've been working on, and there's a lot more that we'll be working on in the coming months. So some of the stuff was GA, the app map, the profiler. Some of the stuff was in public preview. That's the automatic snapshots collected by Application Insights. We also have a private preview of the Visual Studio snap points and log points. And so we encourage you to sign up for those features to get feedback. And all of this will be available for you to use this summer. And we'll be available at the diagnostics booth in the hub if you want to chat more.
I'll actually be down there after this talk. So if you have any more questions, you can feel free to come by and talk to us.
Here are some related sessions you might be interested in. Learn more about monitoring solutions with Azure on Friday. More about the runtime with Scott Hunter and .NET. I think that happened earlier today. And for more about the future of Visual Studio, check out Amanda Silver's talk. And then I also have a talk about all of this stuff, but in microservices, if you want to watch the online video. So thank you, everyone, for your time today. Again, we're really excited. Thanks for everyone for coming to be here. Please fill out your evaluations. and have a great Build 2017.
Thank you very much.